Right, so this is example 1. If the equations we are given two quadratic equations, 2x squared plus bx minus 15 and 2x squared minus bx plus 6 equals 0. So just by looking at these two quadratic equations, you know that this one is not a common multiple of the other. One is not a integer multiple of the other. So these are two different quadratic equations. But here the coefficient of x is not mentioned. It is a variable here, b. So we can take any values. B is a real number. We can take any value, but we need to know what values that has to be applied, that has to be substituted for b, such that both quadratic equations have one root in common. So we can have as many values for b as we want, but for some values for b, these two quadratic equations will have one root in common. So that is the idea here. So what I'm going to do, so I'm going to start this one. Suppose alpha is the common root. Suppose alpha is the common root. If they mention the common root is alpha, then take it. Otherwise, you can take the common root as alpha. That's totally up to you. Or beta or gamma, whatever it is. Right. So when you take the common root as alpha, you can have two relations, which means this equation is satisfied when you replace x with alpha. So alpha squared plus b alpha minus 15 equals 0. Right. Next one 2 alpha squared plus b alpha plus 6 equals 0. This is equation 1, equation 2. Now here's the thing. So we have b and alpha. They are both included here. So two unknowns are there. So we have to find values of b such that these two equations have a common root. So what we are going to do? First thing we can do is to find alpha. We know that there are two ways we can use to get values for alpha. Then we can substitute the values for alpha using the other one. So actually they are asking for the values of b. So what is b? B is a coefficient, right? B is a coefficient. So in a way, what they are hinting out is that to make us to find the relationship between the quadratic equation, the relation between the coefficient of the quadratic equation. That's what they are hinting at. So we should do that. First, get rid of alpha squared. So sorry, this has to be negative. Now, we can get rid of alpha terms. So b alpha is there. If we get rid of this one, we would get alpha squared equals something. And we would get alpha squared equals something which does not have b there, right? So I can just add these two up. 1 plus 2. These two cancel. This 2 would be 4 alpha squared, cancel out, and this would be minus 9 equals 0. So that is, this implies alpha squared equal 9 by 4 and alpha equal plus or minus 3 by 2. So we have two values for alpha. There are two values for alpha, right? So one alpha being 3 by 2, the other one being minus 3 by 2. Right. So now what we can do? We found alpha, but they are asking us to find b. They are not asking us to find alpha. Now to find b, what we can do is we can just replace alpha from one of these equations by this value and obtain b. So that's what we can do. So we have two alpha values there, which means we would get two values for b. So suppose alpha is plus 3 by 2. In this case, alpha is plus 3 by 2, then I can use equation 1. So 2 into alpha squared is just 9 by 4 plus b 3 by 2 minus 15 equals 0. So here I get 2 and the value of b would be here. Let me just write down the value. Right. So when you substitute alpha equal plus 3 by 2, you get b equals 7. When you substitute alpha equals minus 3 by 2, you get b equals minus 7. So that means there are two values of b for which these two quadratic equations will have one root in common. For any other b values, they will not have any roots in common. හරි. තර මේක තමයි general approach එක. මේ වගේ ගණන් ගොඩක් අහලා තියෙන විභාගෙදී constant unknown එකක් දීලා එතන මේ දෙකේම මේ unknown එක තියෙන්න පුළුවන් ඕනම තැනක. ඊට පස්සේ අපි කරන්නේ මේ system එකේ ගිහිල්ලා අපි value එකක් අරගෙන ඒක ආයි මේ substitute කරලා අදාළ constant එක හොයනවා. දැන් මෙතනදී බලන්න මෙතනදී මම කරේ 1 plus 2 ගත්ත ගමන් මට alpha squared ආව b නැතුව. You can see we don't have any b terms here. Simultaneous equation වල කරන්නේත් අපි ඒකම තමයි අපි කරන්නේ එක unknown එකක් අයින් කරගන්නවා. ඉතින් මේ unknown එක අයින් කරගත්තා. දැන් මෙතන unknowns දෙකක් තියෙනවා. alpha b. මේක සාමාන්‍ය simultaneous equation වගේ නෙමෙයි. මේක ටිකක් වෙනස්. හරි. alpha b දෙන්නම එකම term එකේ තියෙනවා. ඒතර මම මුලින්ම මේ දෙන්න මම මෙයාව අයින් කරගෙන මේ alpha squared අයින් කරගෙන ඉන්නේ නැහැ. මේ දෙන්න ඩිඩක්ට් කරොත් මට alpha squared term එක අයින් වෙනවනේ. එහෙම වුණොත් මට කෙලින්ම එන්නේ b alpha equal මොකක් හරි කියලා. හරිද? එතකොට b එකයි alpha යි දෙකම equation එකේ තියෙනවා. නමුත් මට මුලින්ම alpha හොයලා ඊට පස්සේ එතකොට ලේසි ඊළඟට b හොයන්න. ඒකයි මම මුලින්ම මේ දෙන්න ඇඩ් කරේ. ඇඩ් කරාම මේ alpha යි b දෙන්නම තියෙන term එක අයින් වෙනවා. අයින් වෙලා alpha විතරක් ඉතුරු වෙලා ආන්සර් කියනවා. ඒක තමයි මේක. Let's look at another example. Right, so in this example you can see if x squared plus ax plus bc equals 0 and x squared plus bx plus ca equals 0 have one root in common. So they state that both equations have one root in common. Find the quadratic equation satisfied by the other two roots. Right, so we know that in general a quadratic equation have two roots. So this one would have two roots and this one would have two roots, but they say that one root is in common. So actually there are only three roots here, right? Three distinct roots. So we know how to find the common root. Common root can be found very easily, and there will be two other roots remaining, one from each quadratic equation. So next thing they are asking us to find the quadratic equation whose roots are the other two roots. So this is what I'm going to do. So suppose let's say alpha and beta are roots of x squared plus ax plus bc equals 0 and alpha and gamma be the roots of x squared plus bx plus ca equals 0. Right. So what does it mean? If now here you can see that alpha is the common root. Alpha is the common root. So we saw that in the theory part you have to find alpha first. After you find alpha, then you can find the other two roots. So we do the same thing. Since alpha is a root, we can write alpha squared plus a alpha plus b c equals 0, equation 1. Then alpha squared plus b alpha plus ca equal 0. This is equal to 2. Now here we saw that there are two methods available. We can get rid of alpha terms and find alpha squared, or we can get rid of alpha squared terms and find alpha. Now you know that in order to find the other two roots, we need alpha, not alpha squared, we need alpha. So it's better to get rid of alpha squared terms from this. So it's easy. You can see the coefficients are 1, so you can do 1 minus 2 and we get a minus b alpha equal ca minus bc. Ca minus bc. So alpha in this case is ca minus bc over a minus b. Ca minus bc, c is common, so you take that out. A minus b, we have a minus b here, so the answer is c. Now c is the common root in this case. Fascinating, right? So we can find the other two roots from based on this one, alpha and beta. So alpha beta equal, alpha into beta must be constant, which is bc divided by coefficient of 1, is just 1, so I'm not gonna write that down, which implies the other root beta is bc over alpha. Now alpha is c, so the other root is b, right? Similarly, what would be gamma? So the gamma would be alpha times gamma would be ca over 1, but alpha is c, so gamma is a. You can see we found beta and gamma in this case, right? Now we have to find the quadratic equation whose roots are beta and gamma. So quadratic equation whose roots are beta and gamma can be found by x squared minus addition of the two roots beta plus gamma x plus the multiplication of the two roots gamma into beta equals 2. So we know what gamma is, we know what beta is. So beta is b, gamma is a. This would be b plus a x. Gamma times beta would be b into a equals 0. Right. So we here what we did was we found alpha, the common root, right? So based on alpha, we found the other two roots, right? So if we know the other two roots, then we can determine the quadratic equation based on the other two roots. Simple, right? So we look into more examples in the class. So thank you for watching.